All right, let's jump into the fascinating three-dimensional world of numbers. Today we're talking all about cubes and cube roots, this fundamental power of 3 that you'll see both builds numbers up and breaks them right back down to their core. So, let's get into it.
So, here's the game plan for this explainer. We're going to start with the absolute basics. What is a cube? Then, we'll get into the rules that make them tick. After that, we'll flip the whole thing on its head and go in reverse to look at cube roots, see what makes them so powerful, and finally, we'll put all the pieces together. It's a pretty clear path to really getting this stuff down.
Okay, first things first. What exactly is a cube? Before we can build anything interesting, we have to make sure our foundation is rock solid.
So let's start with the most important question. When you hear someone say cube a number, what are they actually talking about? It's an idea that's way more than just a little box shape.
At its heart, cubing a number just means you multiply it by itself 3 times. That's it. Take the number 2, for example. You go 2 times 2 times 2, and you get 8. And you can literally picture this, right? Think of a cube where the length, the width, and the height are all 2 units long.
And, this whole concept isn't just for neat little whole numbers. Cubing works for any rational number. We're talking positives, negatives, even fractions. Basically, if you can write a number as a fraction, you can cube it.
Now, when the number we're cubing is an integer, a whole number, the result is something special called a perfect cube. These are those nice, clean results with no messy decimals. So 27 is a perfect cube. Why? Because it's just 3 times 3 times 3. You want to keep these perfect cubes in mind. They're going to come in handy later.
Now check this out. What's really interesting here is just how quickly these numbers grow. The cube of 1 is just 1. Easy enough. For 2, it's 8. But by the time we get to 5, its cube has already exploded to 125. This massive jump, this exponential growth, is a really key part of what cubing is all about. This little table shows the first few you'll probably want to remember.
So, we've got a handle on what cubing is. Now let's dig into the rules. How does this whole operation work when we start throwing different kinds of numbers into the mix, like negatives?
Okay, here is a super important point, a really simple but powerful rule. When you cube a number, its sign, it stays the same. A positive number stays positive, and a negative number stays negative. The sign just carries right on through the whole calculation. And you can see that rule playing out perfectly right here. On the left, cubing a positive 2 gives us a positive 8. Makes sense. But look at the right. Cubing a negative 2 gives you a negative 8. Why? Well, think about it. A negative times a negative gives you a positive, right? But then that third multiplication by a negative, boom, it flips the result right back to negative. It's a simple and, more importantly, a really consistent rule.
Okay, so we figured out how to build numbers up. Now, let's learn how to take them apart. It's time to work backwards and get into cube roots. And this is where we get to put on our detective hats.
The main tool for our little investigation is the cube root, and it's represented by this symbol right here. Since it's the exact opposite of cubing, its whole job is to answer just one question. What was the original number that got us here in the first place?
I absolutely love thinking about it this way. The number you're given, let's say 27, well, that's the scene of the crime. The cube root is the detective who comes in, looks at the evidence and says, aha, the culprit, the original number that did this, was 3. It just makes the whole thing feel so much more intuitive, doesn't it? So, what kind of tools does our mathematical detective have in their toolkit? Let's take a look at the powerful properties of cube roots. Just like with cubing, these properties give us a great framework for cracking even more complex problems. The big idea here is just how versatile these things are. Cube roots can handle positive numbers, no problem. But, and this is a big difference from square roots, they have absolutely no issue with negative numbers either. This lets us simplify tricky fractions and untangle complicated expressions, making them way easier to deal with.
All right, we're in the home stretch. For our final section, let's pull all these ideas together. We're going from theory to actually doing it, from concept to calculation.
So how do you actually use this stuff? It's a really simple 3-step process. First, just look at the number inside that cube root symbol. Step 2, you ask the detective question. Okay, what number when I cube it gives me this value? And then, step 3, you just write down that original base number. And that's it. That's your answer. If you only take one single thing away from this explainer today, let it be this. Cubes and cube roots are 2 sides of the exact same coin. They are perfect inverse operations. Cubing builds a number up with a power of 3, and the cube root breaks it right back down to its original foundation.
And that pretty much wraps up our look at cubes and cube roots. But of course, with numbers, the exploration never really ends, does it? Now that you kind of understand this third power relationship, it makes you wonder, what about the fourth root? Or the fifth? What other mathematical structures are just waiting out there for us to figure out?